Right now, the Earth is spinning at 1000 kilometers per hour, but why aren't we feeling it? Inertia is the answer most people give for this question, but that's not completely accurate. It's the same as when you are inside a plane going 800 kilometers per hour but can't really feel that speed. Dropping a pen aboard an airplane will result in it falling vertically relative to you. The reason behind that is that you, the plane, and the pen are all moving together the same constant speed, so unless the plane suddenly brakes, no one is feeling this speed. But this isn't a completely accurate answer because Earth is not going in a straight path, it's also revolving around its own axis and around the sun. If a plane makes a sharp turn, rest assured everyone will feel it, but we aren't feeling it in the case of the Earth because it's revolving non-stop for 24 hours a day, so the turn we experience is so gradual it's impossible to perceive. But there is a way to measure this revolving. Scientists experimented a lot with releasing objects from tall towers and watching them fall, and the result is that those objects slightly deviated by a few centimeters towards the east from the expected place they were supposed to fall at, because east is the direction Earth rotates towards. But there is a better method. In 1851, a person by the name of Leon Foucault came up with a very creative way to measure the spinning of the Earth. He used the pendulum suspended from a high ceiling with sand spread on the ground below. When you give this pendulum a push, it swings back and forth, drawing a line in the sand. But if we leave the pendulum swinging for some time, we will find the line in the sand has rotated. But wait, how can the line move if both the sand and the pendulum are on planet Earth? Well, it turns out the pendulum isn't actually changing direction at all. The pendulum's wire is attached to a pivot with a very well lubricated mechanism where friction is nearly zero, which allows the pendulum to swing in the exact same plane relative to the universe. What's actually happening is that the Earth and the sand below are rotating beneath the pendulum, while the pendulum maintains its original direction of swing. Imagine drawing a straight line while someone slowly rotates the paper beneath your pen. From your perspective, you're drawing straight, but the line on the paper appears curved. The pendulum uses the law of inertia to establish a non-rotating reference frame in space, with everything around it, including us, rotates with the Earth. This apparent rotation of the pendulum's plane relative to the ground is called precession, and it provides direct, visible proof that Earth is spinning.